Hey folks, welcome to my channel Number Pen. So there we have the problem on our screen. Differentiate the following. We have x square plus 4x plus 6, the whole power 5, right? So in this video, we're going to learn differentiation by substitution, right? So I'm going to start off by writing out what is my equation, y. Y equals x square plus 4x plus 6, the whole power 5, right? And so you see that y is an expression of the type function raised to the power n, right? And instead of the function being x, right, we have a quadratic equation which is x square plus 4x plus 6, right? We know that d by dx of x to the power n equals, I'm going to write it out here, folks, for you. We know that d by dx of x to the power n equals n into x to the power n minus 1, right? Now we have a very similar expression, right? And then instead of x, we have x squared plus 4x plus 6, right? I want to draw your attention to the composite theorem, which we have discussed in our earlier videos, and I'll be putting a link to that particular video in the description. And if you haven't taken a look at it, request you to take a look at that video to understand before we go ahead and solve these problems. So what does the theorem state? What does the composite rule state? I'm going to paste it out. This is my chain rule or the composite rule in differentiation. Y equals f of u be a function of u, and in turn let u equal g of x be a function of x, so that y equals f of g of x, right? Then my d by dx y equals d by dx of f of g of x, which is equal to f dashed of g of x into g dashed of x, right? So So what is my u here, right? My u, I will have to make a substitution of the expression x squared plus 4x plus 6 equals u, right? So let us do that. My u in this particular case is x squared plus 4x plus 6, right? And therefore my y becomes equal to u to the power 5, right? So now you see that I'm able to express my y in terms of u, and then u in turn is dependent on x, right? And what is my u? My u is nothing but x squared plus 4x plus 6, right? So that's my u, and my y in terms of u is equal to u to the power 5 now, right? And what does the composite theorem state? What does the composite rule state? My d by dx of y equals d by dx of f of g of x equal to f dashed of g of x into g dashed of x, right? Now let's go ahead and substitute and see what we get, right? So we have to find d by dx of y in this expression, and I am going to write my d by dx here. I can also write this as, watch this out closely, folks, my dy by du into du by dx, right? This does not change my dy by dx, right? So what is my dy by du? My dy by du is dy by du of u to the power 5, right? I'm going to highlight this in green. We know what is this. It is 5 times. Again, I go back, draw your attention to d by dx of x to the power n, right? And I'm going to apply the same formula here. I bring my n and then my u to the power 5 becomes u to the power 4, right? So d by du of u to the power 5 equals 5 times u to the power 4, right? So this is my part 1, which is my dy by du, right, folks? We're looking at dy by du now. I'm highlighting it. And now I'm going to move and let me highlight this in yellow, which is my du by dx, right? So where do I get this du by dx from? Here again, right? Whatever you see in yellow is du by dx, right? And what is my du by dx? So I apply the sum rule of differentiation. So my du by dx is nothing but d by dx of x squared plus 4x plus 6, which is again through sum rule of differentiation. I get my d by dx of x squared plus 4x plus 6 as d by dx of x squared, which is 2x, plus d by dx of 4x, which is nothing but 4. And then I have d by dx of 6, which is nothing but a constant, and therefore it is a 0, right? So now we have an answer in front of us, but we have a u, right? And we'll have to go back and represent everything in terms of x, right? So how do we do that? I just go ahead and substitute my u uh, with x squared plus 4x plus 6. So 5u to the power 4 becomes 5 times x squared plus 4x plus 6 the power 4, right? And then I have my 2x plus 4, right? So that's how I write my final answer. So, what exactly are we doing here? All that we are doing here is we have a function f of g of x, and my g of x is nothing but x squared plus 4x plus 6, right? And so when I've been asked to do a d by dx of f of g of x, I do my f dashed of g of x with respect to g of x, right? Which is what we have called out as u here. My g of x is nothing but my u. So I do the differentiation of f with respect to u, and then I treat my g of x separately and I go ahead and differentiate it. And my chain rule states that my d by dx of an expression f of g of x is nothing but a product of these two, derivatives, right? So that is why, you end up with the derivative of y as 5 times x squared plus 4x plus 6 raised to the power 4, which is your first part, as in you differentiate the entire y with respect to the function x squared plus 4x plus 6, which is y u, and then you go ahead and differentiate the u, which is 2x plus 4, right? And that's how you arrive at the final answer, right? And I hope you found this content useful. Please do subscribe to my channel and support. Thank you.